Question 6. Question 6, I have the fx given. The factor is x squared minus 2x. So upon reading the word called factor, I'm going to use my factor theorem. Let's form the concept. So polynomial equals to the divisor. Divisor is now called a factor because there's no remainder, right? Factor implies that the remainder is 0. So back to the equation. Divisor times quotient plus remainder. The remainder is 0. I'm going to further factorize the divisor. There's no remainder. You have two good numbers. One is x equals 0. One is x equals to 2. Let's substitute x equals to 0 first. So when x equals to 0, you put it into the left-hand side and the right-hand side. f0 equals to 0. Now when x equals to 0, if you look at the expression here, when x is 0, you're just basically going to get 0 minus 0 plus r. What's left is just r. So r equals to 0. That's the first item. I'm going to sub in x equals to 2 right now. Sub in x equals to 2. Okay, so when x equals to 2, put it into the polynomial here. f2 equals to 0. f2 implies your x is 2. Okay, let's do the substitution now. Okay, be careful of what you are copying. Plus r is 0. Okay, so I simplify this. Okay, so 4p minus 8q equals 0 divided by 4, make a number smaller. Let's call this equation number 1. Okay, call this equation number 1. Continue reading. When fx is divided by x minus 1, the remainder is 8 more than when it's divided by x plus 1. If I do by concept, the first thing comes to my mind is the first remainder is 8 more than the second remainder. The first remainder, this is given by f1. If I form an immediate response, basically f1 is 8 more than f negative 1. Let's remember that f1 is the remainder. F negative 1 is also called the remainder. So we have the first remainder called f1. I have the second remainder called f negative 1. If this makes sense to you, then you use this because it's actually a faster way. If somehow you still can't get the concept, it's okay. I'm going to do the DQR again. Now I have two divisors here, so that corresponds to two equations. The first equation, fx is equals to divisor times quotient plus remainder. The second equation, fx is divisor times quotient plus remainder. So the first statement, when x is 1, let's observe when x is 1. When x is 1 is f1. f1 equals to 0 plus r1. Alright, so based on the first statement, you can see that f1 equals r1. From the second equation, I'm going to sub in x is negative 1. So f negative 1 equals r2. So to get remainder 1 is f1. To get remainder 2 is f negative 1. That actually forms the red color statement, the immediate response. So f1 is the first remainder. First remainder is 8 plus the second remainder. So let's try to get f1 and f negative 1 first, okay? Okay, so R1 is F1, right? F1 implies that you're going to substitute your 1. Okay, careful of what you're copying. There's a lot of variables here. Your x is 1 plus R. Okay, so when I simplify this, I will get negative 2. Next, I'm going to get R2. R2 is F negative 1. Again, please remember to put brackets if necessary. Okay, I'm going to simplify this. Okay, so this will be minus 2p minus 5q. Let me highlight that. So the first remainder is called negative q. The second remainder is called negative 2p minus 5q. And these two I'm going to sub it into the relationship as we were saying earlier on. f1 is 8 plus f negative 1. Okay, so let's form the connection right now. f1 is 8 plus f negative 1. f1 was negative q just now. f negative 1 is negative 2p minus 5q. Okay, so 4q equals to 8 minus 2p divided by 2. Divided by 2. I intend to make p the subject. Let's call this simultaneous number 2. Okay, solving simultaneous 1 and 2, okay? Substitute equation 2 into equation 1. So 4 equals to 4q, q equals to 1. Substitute q equals to 1 in equation 2. So your p is just 2. So p2, q1.